Welcome viewers. In this video we'll see the AC terminology. First we'll see the waveform. The waveform is nothing but the graph drawn between the alternating quantity with respect to the time. The waveform is the important term in AC terminology. In case of DC, the voltage or current is always constant, direct current, always constant irrespective of the time. For the given time, for any time, the voltage is constant in case of DC. But in case of AC, alternating current means it is keep on alternating, that is changing from positive to negative with respect to time. So the waveform is very important in case of AC terminology. The alternating quantity may be either voltage, current or flux. We can take either voltage or current or flux. There are so many type of waveforms available. We will see these waveforms one by one. Let us assume that the alternating quantity is voltage. The alternating quantity may be voltage, current or flux. Here we assume that we will take the voltage as a reference. First we will see the sinusoidal waveform, sine waveform. So this is a graph drawn between time and voltage. You see that from 0 to pi the voltage is positive. From pi to 2 pi the voltage is negative. So we have positive cycle and negative cycle, alternate. The voltage is alternate between positive to negative. From 0 to pi means 0 to 180 degree, the voltages keep on increases, reaches the maximum value, again decreases, again reaches the 0 value. It is in terms of sine theta. The increasing and decreasing the voltage is a function of sine theta. So that it is called a sinusoidal waveform, sine waveform. From 180 to 360 degree, same thing repeated, but it's a negative cycle. So that positive and negative voltages are keep on changing, so that it is called a alternating quantity. Alternate means positive to negative, negative to positive, like that it will go. So due to that it is called as a sine wave, as a alternating quantity. We will see the some other waveforms, triangular waveform and rectangular waveform. This triangular waveform, it is in the form of triangle, so that is called a triangular waveform. From 0 to pi the voltage is positive, pi to 2 pi voltage is negative. That is voltage keep on increases, reaches the maximum value, then decreases, again reaches the max 0. The same thing repeated in a negative region, negative voltage. It is look like a triangular, so that is called a triangular waveform. Then we'll go to the rectangular waveform. The graph drawn between time and voltage. From 0 to pi the voltage is positive. From pi to 2 pi the voltage is negative. So we will get positive voltage and negative voltage. So that's called a alternating waveform. It's look like a triangular. It's look like a rectangular. So that is called a rectangular waveform. So alternate means positive cycle and negative cycle keep on changes. We'll go for some more waveforms, sawtooth waveform and trapezoidal waveform. So sawtooth waveform, it look like a sawtooth, so that is called a sawtooth waveform. So here the voltage is maximum, then reaches the 0 value at 2 pi. Again from 2 pi to 4 pi the voltage is again maximum and reaches the 0 value. But here the voltage is always positive. So this is not a alternating quantity. This is a non-alternating quantity. Alternate means the positive and negative will change continuously. Positive cycle, negative cycle, positive cycle, like that. But here always we have positive voltage. So this is only this waveform is a non-alternating quantity. We'll go to the trapezoidal waveform. It looks like a trapezoidal. So that is called a trapezoidal waveform. 0 to pi we have positive voltage. So initially 0 increases, reaches the maximum value, then constant for some time, again decreases, reaches the 0 value. Same thing repeated in a negative cycle from pi to 2 pi. So we have positive and negative. So that's called a alternating quantity. So only this waveform is a non-alternating. The remaining waveform also are all alternating waveforms. Now we'll go to the remaining terms of the AC terminology. The remaining terminology we'll explain with this diagram. Now we'll consider the sine wave, sinusoidal wave. The waveform vary with the sine theta, so that is called a sine wave. That is sine 0, sine 90, sine 180, sine 270, then sine 360. Like that is keep on changes. The sine of theta, so that is called a sine wave. Is drawn between time period and voltage. See, at 0 degree the voltage is 0, then keep on increases, reaches the maximum value. That is here sine theta equal to 0 degree, here sine theta is 90 degree. In between it varies from 0 degree, 10, 20, 30, 40 like that. Thereafter again decreases and reaches the 0 again at pi 180 degree. Then same thing repeated in the negative cycle. Again the waveform increases in the negative region, reaches the maximum value, then decreases and reaches the 0 value at 2 pi 360 degree. So from 0 to pi 180 degree the voltage is positive. It's called a positive half cycle. From 180 to 360 we have negative voltage. So this is called a negative half cycle. The sum of these two, positive half cycle and negative half cycle, is the full cycle. The full cycle is nothing but sum of positive half cycle and negative half cycle. This is one cycle, changing from positive to negative. Positive quantity to negative quantity, completing the positive quantity to negative quantity from 0 to 360 degree is called a one cycle. In that we have two. Up to this is the positive half cycle because it is half of the waveform. So that positive half cycle. This is remaining half cycle. So negative half cycle. Right. So the cycle is nothing but completing one positive as well as negative voltage, that is up to 360 degree. In that we have positive half cycle and negative half cycle. So this is the nothing but time period. The time taken to complete one full cycle, that is positive as well as negative. The time t is nothing but the time taken to complete positive cycle as well as negative cycle, one complete cycle. The frequency, you know that frequency equal to 1 divided by t. The number of cycles per second that can be calculated 1 divided by t. T is nothing but time period. So what is amplitude? The maximum value is called the amplitude, where it is available at pi by 2, that is sine pi by 2, sine 90, we have maximum value. So this is the maximum value. Amplitude is nothing but maximum value. So here 0 then keep on increases, at this point only it reaches the maximum value. So that this amplitude is nothing but a maximum value. This value is nothing but a amplitude. Now we'll see this one by one. What is cycle, what is time period, what is frequency, what is mean by amplitude, everything we explained with the diagram. Now we'll see the definition. Right. Cycle is nothing but it is a set of positive and negative portion of the waveform. One cycle means it is the completing one positive cycle as well as negative cycle. Then what is time period? The time required for an alternating quantity to complete one cycle. One cycle means positive as well as negative. Is called a time period. Is denoted by t. The cycle is nothing but set of positive and negative. The completing this positive and negative is called a time period. Then we'll go to the frequency. Frequency is nothing but 1 divided by t. The number of cycles per second is called a frequency. So cycle means positive and negative. So completing one positive and negative per second. Within a second, how many cycles are completed is called a frequency. It is denoted by F. The unit will be cycles per second or in hertz, or it is called a hertz. F equal to 1 divided by t. Then amplitude. What is amplitude? It is a maximum value. We already referred in the diagram. The alternating means the positive negative changes, the value also keep on increases and decreases. In that maximum value of the alternating quantity in a cycle is called a amplitude. The maximum value is called a amplitude. Already we referred in the diagram. It is also called peak value or crest value. Peak value means peak means maximum. Now we'll go to the remaining terminology. The next term is the average value. What is average value? See, the waveform keep on increases, keep on changes from initially 0, then reaches the maximum value, again 0, again going to negative. So values keep on changing. Average value means we need to add all the terms from 0 to 360 degree. If you add all the individual values, that will give the average value. That is a general. In case of alternating, what is the meaning? The average value of an alternating current, here we refer the current, is defined as the DC current which transfer across any circuit the same charge that is transferred by alternating current during the same time. So the average value in general is nothing but by adding all the value divided by total will give the average value. Similarly here also same, but the definition is DC current to alternating current. Suppose the DC current is transferred across any circuit. The same charge as is transferred by alternating current is called a average value. Right? One circuit is available, in that DC current is passed. For the same time, what is the alternating current is passed for the same charge is nothing but a average value. So what is the formula? I average. Now we are referring current. Voltage also we can take. 1 divided by pi, 0 to pi I d theta for symmetrical. What is mean by symmetrical? Positive and negative. If you have positive cycle and negative cycle is called a symmetrical. Right? The positive cycle same thing will be available as a negative also. So this is the symmetrical waveform. Here we have positive and negative. If you put one line here, this both the sides are equal. This is positive, this is negative. So that is called a symmetrical waveform. So in that case we can take only one cycle, only one half cycle, because next cycle also same. Positive cycle is very similar to negative cycle. Only the thing is the polarity will change. Right? So that we will take 1 by pi up to 180 degree. The limit also 0 to pi I into d theta. So this is nothing but taking the average from 0 to pi, each and every value we are integrated, so that we will get average. In general, average mean I1 plus I2 plus I3 up to In divided by n. Like that here we are doing integration, so that we will get the average value. So a symmetrical waveform means positive half cycle and negative half cycle are equal. So we can take only one positive half cycle, only one half cycle. No need to take the full cycle. So that it is 1 by pi, 0 to pi I d theta. In case of unsymmetrical means it's not a alternating quantity. Right? So here we need to take full cycle. It may be is a non-uniform. So that we need to take full cycle 1 by 2 pi. 360 degree. 360 degree only the one full cycle. Here we are considering full cycle. Here we consider only half cycle, because next half cycle also very similar, symmetrical. So 0 to 2 pi I d theta for unsymmetrical. Right? If it is symmetrical, we can take only half of the cycle. If it is not symmetrical, we need to take full cycle. So what is the current waveform? Current, the expression I equal to Im sin theta. So this current is vary with the theta. If theta is 0, current also 0. Theta is 90 degree, 90 means 1. So current will be maximum. 180 means again 0. 270 means minus. 360 means again 0. So based on the theta value, the I will changes. This Im is nothing but the maximum value. Maximum value. That's called the amplitude, maximum amplitude. So I equal to Im sin theta is the general waveform for a sine wave. The I varies with the function of theta. Now we'll go for this average value. We'll substitute this I as Im sin theta. Now we'll find the average value of the sine wave. So I average equal to 1 by pi, 0 to pi I d theta. Because of symmetrical, we consider only 1 by pi. So 1 by pi 0 to pi, I is nothing but Im sin theta into d theta. So this Im is constant, we'll take outside Im by pi 0 to pi sin theta d theta. So Im by pi, the integral sin theta is minus cos theta. That is, you need to substitute the limit 0 to pi. I will substitute the limit. So Im by pi minus cos pi. While substituting lower limit, one negative will be there. Already one negative is there, so it becomes positive. Plus cos 0. So cos minus cos pi, upper limit substituted, lower limit plus cos theta, cos 0. Here negative is there, while substituting lower limit, one more negative will be there, so it becomes positive. So Im by pi, the cos pi value is minus 1. Already one minus is there. Cos 0 value is 1. So that Im by pi minus minus become 1. 1 plus 1. So that's 2. So I average equal to 2 Im by pi. Right. So here 1 plus 1 2. So 2 Im by pi. That is nothing but 2 by pi is 0.637 Im. So the average value of current in a sine wave is nothing but 0.637 Im. But in average value, what is the disadvantage? We have one positive cycle and one negative cycle. If we add positive cycle and negative cycle, it becomes 0 because of polarity. One is plus, one is minus. So while adding these two, we will get 0. So for that, we can go to the root mean square value, RMS value. That is, the current is squared. While taking the square, what will happen? The negative become positive. Then we will take square root. So the originality will not change. Right. So in the average value, during positive half cycle, the voltage is positive, but during negative half cycle, the voltage is negative. If we add both, it becomes 0. So that we go for the root mean square value. We'll see what is meant by root mean square value. So root mean square value, in order to avoid the average value becomes 0 due to positive negative, we'll go for the root mean square value or effective value. That is, while taking the square, the negative become positive. Again we are taking the root, so it become normal. So what is the definition? The steady current which when flowing through a given resistor for a given time produces the same amount of heat that is produced by alternating current. When the current is flowing through the same resistor for the same time is called a RMS or effective value of an alternating current. Again the definition is, what is the definition? The current is flowing through a resistor for a given time. At that time heat is produced. For the same time and same current, what is the heat produced in the when the alternating current is flowing? So this is the definition. The current flowing through the resistor for a given time, heat is produced. For a DC current, what is the heat produced? And for the same, what is the heat produced for alternating current? That is the definition. Now we'll see the waveform. We will see the equation. So again we have the unsymmetrical and symmetrical. Symmetrical mean we can take 1 by pi, only half cycle. Unsymmetrical mean we have to take full cycle, 0 to 2 pi. So here what we are doing, I RMS square equal to I square. Here taking I square. If you take square, what will happen? During positive half cycle, the current is plus I. During negative half cycle, the current is minus I. But while taking square root, it become positive. So it will not 0. Plus I and minus I will not 0. Both it become positive. So that we are taking square. So the negative term will be converted into positive while taking square. But again we are taking the, here also we are taking square, or we can take square root, so that the originality will not change. So here what is that? 1 by t 0 to t I square dt. This is a general term. T is nothing but the time period. It may be 2 pi or pi, or t by 2 means half cycle. So this is a general formula. The t may be 2 pi or it may be pi. Now we'll go to the alternating quantity. We'll see the RMS value. So I equal to Im sin theta. We already discussed. So I square RMS. So we are here that square is done on both the sides. So the negative become positive. 1 by 2 pi 0 to 2 pi I square d theta. But here only we have 1 by pi is enough, right, because it is a symmetrical value. So 1 by pi 0 to pi I square d theta. So 1 by pi 0 to pi I square is Im square into sin square theta d theta. This Im square sin square theta into d theta. Now we consider only half cycle because it is symmetrical. The sin square theta, before integrating we need to change it. So the sin square theta is written as 1 minus cos 2 theta divided by 2 into dt. This Im square is taken outside because of constant. So Im square divided by pi integral 0 to pi 1 minus cos 2 theta divided by 2. Sin square theta is now changed into 1 minus cos 2 theta divided by 2. Now we can easily integrate this. This 2 also taken outside. So Im square divided by 2 pi into the integral 0 to pi 1 minus cos 2 theta into d theta. Now we need to integrate this. We'll go refer here. I RMS square equal to Im square divided by 2. So the integral 1 is, that is d theta. Integral d theta is theta. Integral cos 2 theta is sin 2 theta divided by 2. Right? These two terms are integrated. Now we'll substitute the limit. First substitute the upper limit pi. So theta is pi minus sin 2 pi divided by 2. Then substitute the lower limit. At the time negative will be there, minus 0. Here already negative is there, so that become positive, sin 0 by 2. So pi minus sin 2 pi by 2 minus 0 plus sin 0 by 2. So the sin pi is 0, sin 0 also 0. Only we have pi. So Im square divided by 2 pi, pi minus 0. That is Im square divided by 2, only pi is available. This pi got cancelled. Right. So what we have, this Im square divided by 2. Im square divided by 2. Now we'll take the square root on both the sides. So that I RMS equal to Im divided by root 2. This Im square become Im, 2 become root 2. So the 1 divided by root is nothing but 0.707 Im. Right. The numerical value available. So I RMS equal to 0.707 times of Im. Now we'll go to the next parameter. So the next is the form factor. There are two factors available, form factor and peak factor. Form factor, what is form factor? It is the ratio of RMS value to average value of an alternating quantity. So this is one reference. What is the ratio between RMS value and average value? It is the ratio of RMS value to average value. For sine wave, we already calculated what is the RMS value and average value. Just now we got the derivation. What is the RMS value and average value? Now we'll substitute. For sinusoidal waveform, form factor equal to RMS value by average value. Now we calculated RMS value is Im by root 2. Average value is 2 Im by pi. Right. So that it is Im by root 2. While going to numerator, it become pi divided by 2 Im. So this Im got cancelled. What we have? Pi divided by 2 root 2. So by simplifying this, which is nothing but 1.11. So for a sinusoidal waveform, the form factor is 1.11. So these two values we already calculated, that is substituted. After simplification we got. So form factor of a sinusoidal waveform is 1.11. Then we'll go to the peak factor. One more factor is available. It's called a peak factor. So it is a ratio of peak or maximum value to the RMS value of an alternating quantity. So it is a ratio between peak value to RMS value. For again we will find the for sine wave. For sine wave, the peak value is Im. The RMS value we already calculated, Im by root 2. So while going to numerator, what will happen? Im into root 2 by pi. This Im by root 2 become root 2 by Im while going to numerator. So Im got cancelled. Only we have root 2. So the root 2 value is 1.41. So the form factor, so this is not a form factor, it's peak factor. It is a peak factor for a sinusoidal waveform is 1.41. The form factor is 1.11. The peak factor is 1.41. So in this video we discuss about the AC terminology, starting from waveform, cycle, time period, everything. Then we discuss the average value, RMS value. Then two different factors, form factor and peak factor. Thank you. Welcome viewers. In this video we will see the Phasor representation of sinusoidal varying alternating quantities. This Phasor representation is the more convenient form. We can easily analyze the quantities rather than equation and waveform. In order to solve the complex problem, this Phasor diagram is very important. We can easily understand the alternating quantities by using the Phasor diagram. Now we'll see the Phasor diagram. So this is a sine wave, sinusoidal sine wave. We will taken as a voltage. The sine wave is nothing but the initially at point 0, at the angle 0, it is 0, then keep on increases and reaches the maximum value at 90 degree. Again it keep on decreases, reaches the 0 at 180 degree. Again increases in negative direction and reaches the maximum value at 270 degree. Then decreases in negative direction and reaches the 0 value at 360 degree. So it's keep on changing, alternating. So that can be represented as a circle. So this is the point 0, right? So initially it is 0, then keep on increasing, then keep on decreasing. So this is nothing but equivalent to the positive half cycle. Again it is increasing in reverse direction, increasing in the opposite direction, then decreasing. So this can be treated as a negative half cycle. So here the alternating waveform that can be represented as a phase diagram, we can easily understand, that is it is keep on rotating, the voltage is keep on rotating, increasing, decreasing, again increasing, decreasing in positive direction as well as negative direction, right? So here we have the point 0, 0 to P. So that is equivalent, this line is drawn, equivalent line is drawn that intersect at this point. So this is the point, nothing but the point P. So this angle is phi, the same angle, this angle also phi, both are equal, right? So here when the voltage increases, the angle also increases, here also angle also increases. So this angle can be easily measured from the Phasor diagram itself, right? So the entire sine wave can be represented as a Phasor diagram for easy understanding purpose. So this EM is nothing but the maximum value of the alternating quantity. This EM is the maximum value of alternating quantity, right? So in order to satisfy this Phasor diagram, there are some conditions available. Any alternating quantity, either voltage or current, can be represented by rotating phasor. Rotating phasor is nothing but this die. This is a rotating phasor. Either voltage or current can be represented as a rotating phasor for satisfying the following condition. The following condition should be satisfied. Then only the sinusoidal quantity, either current or voltage, can be represented by the rotating phasor. What is the first condition? The magnitude of rotating phasor should be equal to the maximum value of the quantity. So the magnitude of rotating phasor should be equal to the maximum that is available. So this is the maximum value. So this is also maximum value. So both are equal. So we can represent this as a rotating phasor. The sine wave can be represented as a rotating phasor because the maximum magnitudes are equal. The second point, the rotating phasor should start initially at 0 and then move in anti-clockwise direction. So here also we are moving in a anti-clockwise direction. The second condition also satisfied. So we are moving in a anti-clockwise direction like this. Starts at 0, we are moving in anti-clockwise direction. Then third condition, the speed of rotating phasor should be in such a way that during its revolution, the alternating quantity completes one cycle. right? While moving the rotating phasor, while moving on full rotation, the alternating quantities should complete one cycle. So that is also is available, that is also satisfied. See this, while completing this one circle, one rotating phasor, here one complete cycle is completed, a positive and negative half cycle is completed, right? So the entire cycle can be represented as a one rotating phasor. So third condition also satisfied. Now we'll go to the in phase, out of phase, the phase angle between the two quantities. Now we'll see the in phase and out of phase relations. So the phase is nothing but the fraction of time period that elapsed from reference or zero position. That is the phase is nothing but elapsed from the reference. How it is deviated from one quantity, how is another quantity is deviated is nothing but a phase. In that the first type is in phase. What is in phase? Two alternating quantities are said to be in phase if they reach their zero value and maximum value at the same time. If two alternating quantities are there, both are starts at the same time and ends at the same time, that is the zero value as well as maximum value is the same time in, that is treated as a in phase. The starts and end at the same time, right? So that is represented in this waveform. Now consider the two waveform. I1 equal to Im1 sin theta, I2 equal to Im2 sin theta. What is this? So this is represented in a waveform. This is I1, this is a waveform I1, it's a sine wave. It starts at 0 degree. This I2, only the amplitude is maximum, amplitude is more. That also starts at 0 degree and ends at the maximum value and reaches the maximum value also same time. There is no phase difference. Both waves are starts at 0 degree itself. Both reaches the maximum at the same time. Again reaches the zero value same time. Again reaches the maximum same time. Again reaches the zero value same time. So this is called a in phase. There is no phase angle between these two waveforms. That also analyzed from the equation. See this sin theta, here also sin theta. There is no more additional angle available. It means that these both are in the in phase, right? So this is the maximum value of first waveform, the maximum value of second waveform. So that is represented in the vector diagram. This I1 and I2, see both are available in the same line. There is no deviation. I1 and I2 are available in the same line, right? So from this waveform we can analyze that. From the above waveform it is clear both I1 and I2 reaches the 0 and their maximum value at the same time, even though they have different maximum value. The maximum values are different, but the 0 and maximum values are reaches at the same time, right? So it is also referred as both current are in phase, meaning that no phase difference between two quantities. It also represented by the vector diagram, right? There is no phase angle between these two quantities, right? So that is also, it is represented by this vector diagram. Now we'll go to the out of phase, the second type. What is out of phase? Two alternating quantities are said to be out of phase if they do not reach their zero and maximum value at the same time. Maximum value and zero values are not reached at the same time. The phase difference between these two quantities are represented in two different forms. One is lag or lead, right? In previous case, both zero value and maximum value reaches at the same time. Here it's not at the same time. It may be lead or lag. It may be the angle will be the leading or angle will be lagging. So based on the two types available. First we will see the lagging. What is meant by lag? The lagging alternating quantities is one which reaches its maximum value and zero value later than that of other alternating quantity. Later. So the lagging means one alternating quantity is lagging with the another quantity. The second quantity will reach the zero value before, after that. The first quantity will reach the maximum value. After some time only the second quantity will reach the maximum or zero value. So there is a later. So it will reach the maximum of 0 value later, so that it is called a lagging. So that is represented by minus pi. I2 equal to Im to sin omega t. So that starts at 0 degree like previous case, but I1 equal to Im1 sin omega t minus pi, right? So the minus refers lagging, right? The pi angle, this pi angle is lagging between I1 and I2. I1 reach the maximum value delaying with an angle of pi, right? So that is represented in the waveform. See this is I2. The I2 starts at 0 and is going, keep on going, sine wave. It's like a normal waveform, 0. But I1 starts after pi. After pi angle only the I1 starts. There is a delay. There is a delay of starting with the current I1 with I2, this pi. So due to this delay, it is called a lagging. So this angle is subtracted, because after pi only the I1 is starts. So that is represented by this negative sign, that is indicated as a lagging. So this is the lagging angle between I1 and I2. I1 starts at 0, but I2 starts after some angle, that is called pi. So this is the lagging angle. So due to the delay, it is subtracted and termed as a lag. So that also represented by the vector diagram. So this is I2 normal 0 degree, it starts at 0 degree, but I1 starts later on, so that it is in the downward. If it is starts earlier, it will go to the upward, positive, this will be negative. So this is the angle between this pi is the angle between I1 and I2, because it starts later, there is a delay, that's why it is given in a downward direction. If it is lead, it will given in the upward direction. So from the above waveform, it is clear that I1 reaches its maximum value and 0 value with a phase difference of pi after I2 reaching. So the I1 will reach the maximum and 0 value at a delay of pi, so that I1 lagging the I2. So I2 reaches normally, but I1 reaches after pi. Now we will see the second type, leading. So the leading is nothing but leading alternating quantity is one which reaches its maximum value and 0 value earlier. Before reaching the one quantity, another quantity will earlier than the other alternating quantity. The previous case it is later, now it is earlier. So that is called a leading. So it is represented by the equation I2 equal to Im2 sin omega t. So it starts at 0, there is no delay, but I1 equal to Im1 sin omega t plus pi, right? So it will start earlier, plus pi. If it is minus pi means later, but it is plus pi, so it starts earlier. So this plus indicates this waveform starts earlier than this second waveform. This plus indicates that it is a leading. So that is represented in the waveform. See this I2 starts as a normal, it starts at 0, but I1 start earlier. Before angle of pi, the I1 starts. Before starting I2, I1 starts earlier with an angle of pi. So that is indicate this is the leading. I1 is leading with the current I2 with an angle of pi. In previous case, lagging, I1 starts later. Here I1 starts early. So due to this earlier, this see the phasor diagram, this is I2, this starts at 0, but I1 starts with an angle of pi. It is leading, so that it is given in the upward direction, anti-clockwise direction. Upward direction. Lagging means will go to downward direction. So this is pi is the angle between I1 and I2. I1 is leading with pi with the current of I2. So that is given in a statement. From above waveform, it is clear that I1 starts already and reaches maximum value before I2. So the I1 is starts earlier, that is I1 is leading the I2. I1 leads the I2. So that is the given by the angle plus pi. So from these two we can able to note down that two vectors are said to be quadrature. Quadrature means exactly 90 degree. There is a 90 degree phase difference between the two vectors if it is quadrature. Two vectors are said to be anti-phase, means 180 degree. In phase means 0 degree. So anti-phase means 180 degree. So in phase means 0, anti-phase means 180 degree, quadrature means 90 degree. So in this video we discuss about the phasor diagram of a sinusoidal waveform. Two types, in phase, out of phase. In that again lead, lag. Thank you. Welcome viewers. In this video we will see the complex J operator. That is, it is used to indicate the complex number having real term and imaginary term. That is a vector quantity. A vector quantity has both magnitude and direction. So that is represented in a two plane as shown below. So this is nothing but a complex number. Now consider A equal to A plus JB. What is A? A is the real term, B is the imaginary term. So that is represented in this graph. So as the x-axis, the real term is available. This is the y-axis. In that the imaginary term is available, A and B. So this is B, the equivalently it is drawn here. So the vector sum of these A and B is nothing but the resultant vector M with a magnitude of A. So A is the nothing but vector sum of small a and b. A equal to A plus B. The A available in the x-axis, that is the real axis. B available in the y-axis, that is called a imaginary axis. The sum of these two is the resultant vector A. So there is a phase, there is an angle between A and B is theta. So what is that theta? Is represent the angle of vector A. Pi is the angle of vector A. And also some more description given. The A is nothing but horizontal component or vertical or active component or phase component. It's a real term. A is the real term. It's also called as horizontal or active or phase component. The B is the vertical component or reactive component or quadrature component. Quadrature means 90 degree. It's an imaginary part. So the A is the real term, B is the imaginary term. It also represented in the another two forms available, magnitude and angle. How will you find the magnitude from this way, from this equation? From this A equal to A plus B, the equation available for this equation, how will you find the magnitude and phase angle? Magnitude equal to square root of A square plus B square, that is square root of real term square plus imaginary term square. So it will give the magnitude. Similarly, the angle alpha can be, this alpha, theta are both are same. Tan inverse B by A, that is imaginary term divided by real term. So normally it is called as this is a rectangular form. This is the polar form. That also we will see later. It's a rectangular form and polar form. The rectangular form contain real term and imaginary term. Polar form contain magnitude and phase angle. How will you find magnitude and phase angle? Simple. This is square root of A square plus B square. Angle is tan inverse B by A. So for our convenience solving the problem, we can either use this rectangular form or this polar form. We will see how to convert the rectangular and polar form. Now we will see about what is the J operator. What is this J operator? Some more details about the J operator. J equal to square root of minus 1. This is a value. Value of J is nothing but J equal to minus 1. If you square on both sides, you will get J square equal to minus 1. That is J into J is minus 1. Right. So during the problem, we can use two values, J square equal to minus 1 or J equal to square root of minus 1. What is this J indicate? This indicates anti-clockwise rotation of vector by 90 degree. If J is available, we can assume that, we can see that it is rotating in anti-clockwise direction with 90 degree. If J square is available, it is rotating the anti-clockwise with 180 degree. If J cube is available, it's 270 degree. So 90 degree will increase. J power 4 means it is 360 degree. right? So the j represents 90 degree. J square, j cube means keep on increasing. So this minus j indicates clockwise rotation of 90 degrees. So far we discussed only plus j, j square, j cube. If it is j minus j, j means anti-clockwise, minus j means clockwise rotation. Then how will you find the value 1 divided by j? We cannot find 1 divided by j, so that in order to convert in the convenient form, it is divide and multiplied and divide by j. This 1 by j is multiplied and divided by j, so that the originality will not change. So 1 divided by j into j divided by j. So that is nothing but j is available here. Denominator 2j available. So j divided by j square. What is j square? J square is minus 1. So j divided by minus 1 is nothing but minus j. So we can simply remember 1 divided by j is nothing but minus j. So this is the detail about the j operator. J means anti-clockwise rotation by 90 degree. If j square j cube means the 90 degree will be added. Minus j means clockwise rotation. 1 by j means it is minus j. Now we'll go to the rectangular and polar form. So the vector can be represented in polar form or rectangular form. What is polar form or rectangular form? A equal to 2 plus j3 is the rectangular form. Real term plus imaginary term with j operator is the rectangular form. So this is nothing but polar form. How will you find this magnitude and angle? Magnitude is calculated as square root of a square plus b square. Real term square plus imaginary term square. How will you find the angle? Alpha equal to tan inverse 3 by 2. That is imaginary term divided by real term. So this is represented by magnitude and angle. Magnitude is 3.606, angle 56.31. So this is a polar form. So both are equal. Here represented with real term and imaginary term, rectangular form. Here represented with magnitude and angle for the polar form. Why we are using these two different form? So during the manipulation, that is during addition and subtraction, we can easily use the rectangular form, because we can easily add these two terms, add or subtract. During multiplication and division, the polar form can be used. Why? We have magnitude angle, so that we can easily use with the polar form. So based on that, we'll go to the some example problems. So first we will see the example 1 for addition. So already we discussed, for addition and subtraction we can use the rectangular form. Subtraction, multiplication and division we can use polar form. So here two vectors available, a equal to 2 plus j3, b equal to 4 plus j5. The question is we need to add both the vectors. So it is already in the polar, in the rectangular form. So you can easily add 2 plus j3 plus 4 plus j5. We need to add both the real terms, 2 plus 4, 6. Both the imaginary terms, j3 plus j5, it is j8. So it is easy. It is easy to add two vectors when it is in a rectangular form. And one more question is, we need to find magnitude and phase angle, that is polar form. How will you find the magnitude? Square root of this real term square plus imaginary term square, 6 square plus 8 square. So that is equal to 10. Then how will you find the phase angle? Tan inverse imaginary term j, real term 8 by 6, 8 divided by 6, imaginary term 8, real term 6, that is 53.13 degree. So in this problem, two vectors available in a rectangular form, that is added. So this rectangular form that can easily added. Real term should be added and imaginary term should be added. From that we calculated magnitude and phase angle also. Now we'll go to the second problem for subtraction. So here another two vectors available, a equal to 2 plus j5, b equal to 4 minus j2. The first question is a minus b. We need to subtract these two vectors. A is nothing but 2 plus j5 minus minus of, we need to put minus commonly, 4 minus j2. Now multiply this negative inside, so that minus 4 plus j2. Now we can add both the real terms. 2 minus 4 is minus 2. j5 plus j2 is j7. So it is easily subtracted when it is in the rectangular form. Just we need to add both the real terms and both the imaginary terms. And one more question is available. We need to find the magnitude. How will you find magnitude? Square root of real term square plus imaginary term square. Real term is minus 2, imaginary term is 7. So the value is 7.28. Then how will you find phase angle? Tan inverse imaginary term by real term, b by a. So 7 divided by minus 2. So that is minus 74.055 degree. So here two vectors available, two are subtracted easily with the rectangular form. One more question, from that we calculated magnitude and phase angle also. Now we will go to the third problem. The third one is the multiplication. The two vectors available, a equal to 2 plus j3, b equal to 4 minus j5. We need to multiply these two and we need to find the magnitude and angle. So it is in a polar form, so it is a rectangular form, so we cannot multiply easily. It is possible to multiply, but it is easy to convert into polar form, then we will go for the multiplication. This rectangular form also multiplication is possible, but it is easier to convert into polar form for the multiplication. So how will you convert this polar form? This magnitude of a is nothing but square root of real term square plus imaginary term square. Real term is 2, imaginary term is 3. So after simplification, what we got? 3.606. What is the angle here? Tan inverse b by a, that is imaginary term divided by real term, 3 by 2. It is 56.31. Now it is represented a equal to 3.606 with an angle of 56.31. So this is the real term, this is the rectangular form. Now that is converted into polar form. So this one can be done by in the calculator also. In the calculator directly you can convert from rectangular form to polar form. This is the normal calculation method. In calculator it is available directly. Similarly the second vector is 4 minus j5. First we will find the magnitude, that is square root of 4 square plus minus 5 square, real term square plus imaginary term square. So the value is 6.403. Angle is tan inverse b by a, imaginary term divided by real term, minus 5 by 4. So it's minus 51.34. So due to negative we got negative sign. So that can be represented magnitude 6.403, angle 51.34. So this is the rectangular form now converted into polar form. So these two can be multiplied easily. These two also can be multiplied, but it is easy to convert into polar form, then we'll go for the multiplication will be easier. So a into b. So a is nothing but 3.606 with an angle of 56.31. B is nothing but 6.43 with an angle of minus 51.34. Then how will you multiply these two? You have to multiply these two magnitudes. For multiplication, magnitudes are multiplied. So 23.089. What about the angle? Angle should be added together. For multiplication, we need to multiply the magnitudes and the angle should be added. 56.31 is added with minus 51.34. Already negative is there, so it becomes subtraction. So it is 4.97. The general format is we have to add both the angles for multiplication. So now we got 23.089 with an angle of 4.97. The multiplication of A and B. Now we'll go to the next example, the division. This is the first vector, A equal to 4 minus j2. That will now convert into polar form. The magnitude of A is square root of a square plus minus 2 square. So the value is 4.472 magnitude. Then angle is tan inverse minus 2 by 4, imaginary term divided by real term, minus 26.565. So it is represented in the polar form 4.472 with an angle 26.565. So this is the rectangular form now that converted into polar form. So another vector b equal to 2 plus j3. Real term is 2, imaginary term is 3. So the magnitude is nothing but square root of 2 square plus 3 square. So the final value will be 3.606. The angle tan inverse b by a, imaginary term by real term, 3 by 2 is 56.31. Now it is represented in the polar form 3.606 with an angle of 56.31. Now this rectangular form of a and b is now converted into polar form of a and b. Now we'll go for the division, a divided by b, a divided by d. So this is the vector a and vector b. How will you divide? You have to divide these two magnitudes. Multiplication will be we multiplied two magnitudes. Similarly here two magnitudes are divided. What about the angle? Angle should be subtracted. In previous case the angles are added together. Now the angle should be subtracted. So this angle, while this angle going into the numerator, it become minus. So both are minus, so it become minus 82.875. The multiple division of these two is 1.24. So this is the final value, a divided by b, right? So for multiplication the magnitudes are multiplied, the angles are added together. For division the magnitudes are divided and angles are subtracted. So in this video we discuss about the complex J operator, then what is meant by polar form and what is meant by vector form, and we discuss the 4 different examples: addition, subtraction, multiplication and division. Thank you.